So now let's move on from how hydrogen bonds help water stick to things to discussing how the hydrogen bonds in water help maintain temperature homeostasis. Well, water has a high specific heat and a high heat of vaporization. Looking at specific heat refers to the amount of heat that 1 gram of something must absorb or release to change the temperature of that substance by 1 degree Celsius. Okay? So consider this. You have a pot of water on the stove. The pot heats up much faster than the water, right? But the same amount of energy, same amount of heat, the same amount of energy is applied to both the pot and the water. So how can this be? Well, every substance has its own specific heat. For example, water, it's 1 calorie per degree Celsius. And for aluminum, such as like an aluminum pot, it's only 0.2 calories per degree Celsius, meaning less energy is needed to make aluminum hotter. Because water has a high specific heat, that means a lot more heat or a lot more energy is needed to change the temperature of water. So why is this important? The key to all of this is that the high specific heat of water minimizes temperature changes to be within limits that allow life to happen. In short, it helps maintain homeostasis within organisms and their environment. Water's high heat of vaporization also helps achieve this too. Heat of vaporization is slightly different, right? This refers to the amount of heat a liquid must absorb for 1 gram of that liquid to be converted into gas, okay? Vaporization, going from a liquid to a gas, requires breaking hydrogen bonds, which is a process that requires a lot of heat energy. Water has a high heat of vaporization, meaning it absorbs a lot of heat when converting from a liquid to a gas. This property means that we can maintain standing bodies of water on our planet, right? They don't vaporize with solar radiation, for example. That would be disastrous to so many living creatures, right? It is also good because it leads to a process called evaporative cooling. Evaporation is the actual transformation of a substance from a liquid to a gas. So evaporative cooling is the cooling of the surface when water evaporates from it due to all the heat absorbed by water. When water evaporates, though, the hottest water molecules vaporize, leaving the cooler molecules behind. So the high heat of vaporization makes evaporative cooling possible. Evaporative cooling of water helps stabilize temperatures in living organisms and in bodies of water.